Welcome to Study Loop.
So first, using Ampere's law, we'll calculate the magnetic field between the conductors. And Ampere's law tells us that the integral of B dot dl is equal to mu naught times the enclosed current, I. And we can see that for this case, this is the magnetic field around the circumference of the cable. So B times 2 pi r is equal to mu naught I. And hence, we can find an expression for the magnetic field. B is equal to mu naught I, where I is the current in the cable, over 2 pi r, where r is the radius of the cable. So hence we have an expression for a magnetic field. Secondly, an infinitesimal flux d phi is equal to B dA, where A is the area of the cable. And we know that B is given by mu naught I over 2 pi r, and A can be written as r as the area is the length times the width element dr. So the length of the cable is L and the width element dr. So an infinitesimal flux is given by mu naught I over 2 pi r times L dr. Next, we wish to calculate the total flux across the cable, and we can do this by integrating the expression above. So if we integrate from A to B of all the flux elements d phi, we get mu naught times I times the length L all over 2 pi times the integral from A to B of 1 over r dr. And hence we get that the total flux over the cable is mu naught times I times the length of the cable over 2 pi times the natural log of B over A, which is what we get when we do the integral. Okay, so that's an expression for the total flux across the surface of the cable. Next, the inductance, we know, is defined as N times the magnetic flux over I, where N is the number of turns. And this is simply L times mu naught over 2 pi, using the expressions above, times the natural log of B over A as required. And finally, the energy stored by the magnetic field, U, is equal to 1/2 times L times I squared. And this is 1/2, and we substitute our expressions above, times L times mu naught over 2 pi times the natural log of B over A times the current I squared. And if we simplify this, we get the energy stored in the magnetic field to be mu naught L I squared over 4 pi times the natural log of B over A. So the magnetic field between the conductors is due only to the current in the inner conductor.